This is Lakshmi Vidya, Associate Professor at Department of Computer Science and Engineering, Vignan's Institute of Information Technology. I welcome you all for the Big Data Analytics IUCE webinar. We will have a discussion regarding Big Data and Hadoop. What is Big Data and how the Hadoop plays a vital role in the Big Data analysis. So all these things we are going to discuss in today's topic. So in today's topic, these are the contents we are going to cover. That is, what is big data, limitations of existing solutions, solving the problem with Hadoop, introduction to Hadoop, and the most important part is Hadoop ecosystem. What are the eco components are there in the Hadoop? That thing we are going to cover. And if time permits, we are going to cover the core components and HDFS architecture, how the map reduce job execution happens, what are the anatomies of file read and write, all these things we are going to cover. But if the time permits, then only we can go for MR code execution and all. So let us start the most important worldwide famous concept, that is big data. So what is a big data? A big data is nothing but lots of data which is measured in terms of terabytes and petabytes is called as big data. So generally, the big data consists of structured data, unstructured data, semi-structured data. So these are all the various kinds of data is a combination of big data. So generally, we define the big data in terms of collection of data sets so large and complex that it becomes difficult to process using the traditional data processing applications. Like we used to process the database management tools by using the Oracle or SQL Server, something like that. We used to perform small issues of analytics. But we are facing a lot of problems in handling the traditional data processing. What kind of challenges we are facing here is capturing is difficult. The most important is storage is difficult. Searching becomes difficult, transferring of files is difficult, and the major part is analysis itself is difficult, and visualization part is difficult. So these are all the major challenges which are present with the big data, which cannot be possible with the traditional data processing applications. Right? Now, systems and enterprises generates huge amount of data, which is measured in terms of terabytes and petabytes of information. So short and sweet, what is a big data? A big data is nothing but lots of data which is measured in terms of terabytes and petabytes is a big data. The big data basically consists of unstructured data, semi-structured data. All these data combination is big data. We will discuss about what these terabytes and petabytes consist of, all these things. So a big data is nothing but, in a short and sweet manner, it's a data set so large and complex that it becomes difficult to process using the traditional data processing applications. So what are the solutions are there for all these things? We are going to see one by one in the next slides. Right. Just for an understanding's sake, I have given an image here. This is the image of New York Stock Exchange market. So what this New York Stock Exchange market is saying, that is, it is generating nearly 1 terabyte of data per trade per a day to perform the stock trading analysis. My God. So what it is, what this image is showing, that is, it is generating nearly 1 terabyte of data per trade in a day. So from New York Stock Exchange itself, we are getting 1 terabyte of data per trade in a to perform the stock market. There are different zones are there in the world. From that locations also we are going to get lots and lots of data. So just for an example sake, I have shown you the New York Stock Exchange market, and this is an example, and I am proving that how the big data is generating a more in the world. So we can see the graph here, and through this graph, I would like to show that how the unstructured data is exploiting. So we can see here from 1970, this is a graph. The blue color is indicating that there is a only growth of relational data. That is also very slowly it is growing. That is called as what? These are all your business transaction data. So what are relational data here? Relational data are nothing but simple structured data are called as your relational data, and these relational data are growing very slowly. There is no drastic changes. But with concern to complex and unstructured data, you can see here from 1990 onwards, there is a drastic change in the generation of complex and unstructured data. So what is this complex and unstructured data? It basically consists of data from Facebook's, Twitter's. These are all the data which is increasing and increasing more, and it is unable to handle them. But with concern to relational data, that is called as structured data and all, which is very slow. Why it is slow? Because we can get the structured data from the enterprise level, from the system generation level, only that part, only hardly we can have what the school maintenance systems or the business transactions, very small things you are going to find in the relational data, that is called structured data. So with this graph, we are proving that the generation of unstructured data is exploiting more compared to the structured data. But one thing I would like to tell you, the big data does not only consist of complex and unstructured data. The big data is a collection of structured, complex, unstructured. It's a combination of all together. So analysis is saying that nearly 2,500 exabytes of new information in 2015 with internet as a primary driver. So this is the analysis of 2012. But if you take the analysis of 2015, obviously it will be more and more. So this graph is showing that how the generation of complex and unstructured data is increasing more and more, that we are demonstrating here. We can see yeah. So IBM has defined the big data as big data is nothing but big data is always bigger in volume. It is increasing and increasing. We are increasing, it's increasing size. So big data is increasing in volume. So it's increasing. So IBM has defined the big data as big data is bigger in volume, big data is bigger in velocity, big data is bigger in variety. So from big data aspect, we can get the big data from weblogs, from audio files, from videos, sensor data, images. So these are all your varieties of data which you find from the big data. So IBM has defined big data as big data is always bigger in volume, big data is bigger in velocity, big data is bigger in variety. So in this manner, the big data has defined the IBM has defined the definition for the big data. Right. Now we can see the big data customer scenarios. What is big data customer scenarios? Big data customer scenarios are nothing but from which zone we are getting a lot of data. So that is called as the common customers. So from which zone we are getting the big data, that is called as the big data customer scenarios. So not only from computer science and engineering world we are getting the big data, from every part, from every corner we are getting the big data. That is the reason there is a big and heavy importance for the big data in the research environment also. There is a lot of research work has been taking place for the big data, because the generation of big data is not only concerned with one area, it is from all the parts. So let us see who are generating the big data and who are the customers of big data. Let us see this. So from web and e-tailing also, there is a generation of big data. So how the generating of big data is happening from the web and detailing? Whenever we are browsing our machines, we have a lots of ads, we have a lot of searching quality. So all these things are generating lots and lots of big data, and everybody is aware of eBay. And right now, eBay is a company which is generating big data from the web and e-tailing part. So eBay is the company which is generating big data from the web and e-tailing part. Big data is generating from telecommunications also. So from telecommunication aspect, we are having a CDR analysis, calling data record analysis. So if you take the example of CDR analysis, from one cell number, how many calls has been happened, and from one cell number, how many calls has been happened for one particular number, and how many minutes he or she has spoken. So all those things are going to be recorded in the CDR analysis. So that is all also a big data, which is also a unstructured data. So it does not consist of any structural information. So big data is generating from telecommunication side also. So from the entire world right now, China Mobile is the company which is generating big data with concern to the telecommunication. So from web and e-tailing part, who is the customer? eBay is a customer which is generating lots of big data. And from the telecommunications side, China Mobile is the company which is generating lots of big data from the telecommunications side. There are other big data customers are there. Of course, government is also generating big data. So how the government is generating big data is, we have Aadhaar cards. So Aadhaar has generated lots of big data from the last 2 years scenario. If you will take, previously we don't used to have Aadhaar card. We used to have only some sort of ration card used to have, and in that ration card we don't used to have all other things, only hardly we used to have the image of the entire family, that's all, and the address proof, all those things used to be there. But now if you take the example of Aadhaar card, apart from that previous old ration card, we have got so many more things in the Aadhaar card, like we are having the eyelid ball, our information, thumb information is there, our thumb information, our image. That means what? In the previous ration card, the whole family used to be there in the one ration card. But now in every individual has got the Aadhaar. So Aadhaar has generated lots of big data. So what is the benefit of this Aadhaar? The benefit of this Aadhaar is nothing but we can provide a proper welfare schemes for the really who wants, because everybody is associated one unique Aadhaar, so one unique number. So who is really deserve for the welfare schemes, and the fraud detection can be applicable, the proper justice can be given. So Aadhaar also has generated big data. So we can say that in a short and sweet manner, the government also generated the big data. So in the whole world, in the whole country, previous 1 year and 2 year onwards, we have seen how people were struggling for the Aadhaar, and now everybody got this Aadhaar, and Aadhaar has generated lots of big data. Big data is generated from the healthcare and life science also. So how healthcare and life sciences have generated big data? So Next Bio is the biggest company who has generated the big data with concern to healthcare and life sciences. So how big data has generated from healthcare and life sciences is, frankly speaking, the more big data has generated from this zone more compared to the previous telecommunication or from the web. Of course, the web part also generated more and more amount of big data. But with concern to healthcare and life sciences, there is a lot of generation of big data. For an understanding purpose, let us take one example. For instance, in a hospital, analysis is going to be, has to be taken part, like how many patients regularly visiting with the diabetics, how many patients are regularly visiting with the BP, and how many patients are visiting the hospital with cancer, what kind of cancers, all these things. So there are not general things. But if you take the example of swine flu will not come in the whole year. Swine flu will come in the month of November, December, January, February. So in the time of cool time, the generation of more swine flu cases will be there. So by taking the analysis of that, the healthcare systems, the pharmaceutical companies starts their production of vaccines for the swine flu. If without performing the proper analysis, if they keep on producing the vaccines for the swine flu and all, the company will win the loss. That is why there should be a proper analysis. Even that is a part of swine flu. Even for the diabetic also, if you will take an example, every year the country celebrates the diabetic day, the world celebrates the diabetic day, and on that day they give a statement that in this year this many cases were arised, and what are the reasons of all those things. So it's going to be shown. So that is going to play a vital role, that people are going to get the information regarding the diabetic and what kind of preventions has to be taken, what kind of care has to be taken. So this is the responsibility of the government to take care about the citizens. So all these things are generating big data, right? So healthcare and life sciences are also generating a big data, and Next Bio is a company which is generating lots of big data with concern to the healthcare and life sciences. Big data customers still if you continue, even from banks and financial services also generating big data. The world's biggest financial service, JP Morgan Chase, is a company. This company is generating lots of big data with concern to banks and financial services. So I believe that almost all part of the area we have covered. We have covered the web part, we have covered the telecommunication part, we have covered the web and e-tailing part, we have covered the telecommunication part. The telecommunication is also generating big data, and government also generating big data, healthcare and life sciences also generating big data, banks and financial services are generating big data. Now coming to the retail point here, so retail point also generating lots of big data. If you take the examples of retail here, there is a sentiment analysis is there. For example, just to have an explanation regarding how the big data is generating with concern to retail, and by taking the example of sentiment analysis, generally people will buy the gold, but there is a purchase of gold will be more during on special occasion, like some days like Akshay Tritiya or Dhanteras. These are all some important days in country like India. So where people like to focus on purchasing of gold on those days, that is called the sentiment analysis. So on that date, on that dates, there will be more purchase of gold with concern to whatever the product rate and all. But to focus towards the sentiment, the people starts buying more amount of gold. So that is also a generation of big data with concern to retail. A small example I'm giving, but if you take the point of sales transactions and all, and customers churn analysis and all, if you take, there is a lot of big data analysis, generation of big data will be more. With concern to retail, Sears is the biggest company which is generating big data, and I want to show you how big data has been produced by the Sears and how Sears is taking care about the big data. So it is a hidden treasure of the Sears, frankly speaking. Sears used to perform its analysis by using Oracle on Teradata. So used to perform the analysis by using the Oracle, but later on, Sears started making use of Hadoop. Why Sears started making use of Hadoop? Because Sears started getting not only the structured data. As long as Sears was working with structured data, Oracle was very fine. Using Oracle, people used to make use of the analysis happily. But with concern to unstructured data, because Sears company, as long as it was working with structured data, because I have shown you the graph of how unstructured data was exploiting. I will show you the graph of how unstructured data was exploiting. So as long as the company was getting the structured data, Sears company working with Oracle to perform the analysis. But as soon as the Sears getting the structured data, unstructured data, semi-structured data, all mixture of data, when Sears started getting, Oracle got failed. Why? Because with Oracle we can perform only structured data analysis, but not the unstructured data analysis. That becomes a problem now. Now Sears started making use of Hadoop. Sears started making use of Hadoop. So till now, in our discussion, we have discussed what is a big data and how big data is arising, and how big data is getting from all the parts, from web and e-tailing, from telecommunication, banks and financials, from retail section, from all the zones we have seen. Now, the question for all the big data problems is, the answer is what? The Hadoop is the answer for the big data. What is big data and what is the Hadoop, that we are going to see now? We have covered the big data. So in big data, we have seen the limitations of existing data analytics architecture. So what are the limitations are there is, only 10% of data is available, remaining 90% is completely archived here. So it becomes slow here, and only working is possible with concern to RDBMS. But remaining is not possible here. So that is the limitations with concern to data analytics architecture. Coming to the what kind of solution we can do for that is, we are going to combine storage computer layer. What is the meaning of that here? We are going to mix up with the Hadoop storage plus compute grid. That means what? We are going to enhance the HDFS, that is called as a Hadoop distributed file system architecture we are going to use here. So this is a solution. From the previous slide, we have seen the drawbacks. Now we have started providing the solution. Like I'm giving a small example. Sears has moved to 300 nodes Hadoop cluster to keep 100% of its data available for processing rather than only for 10%. So how these people previously, in the previous slide we have seen only 10% data was used for processing and remaining 90% was in archive state. But now it is now changed completely. All 100% data is available, and what was the solution previously? 10% was using because of non-Hadoop solution. But with the Hadoop solution, we are making use of what 100% of data can be used here. So how Hadoop is performing its job, we are going to see now. So before going ahead, I would like to talk about what is a Hadoop. Then we are going to go to the previous slides. So Hadoop is Apache Hadoop is a framework which allows for distributed processing of large data sets across clusters of commodity computers using simple programming model. So what is the Apache Hadoop? Apache Hadoop is a framework, an environment which allows for distributed processing and on large data sets. So now the question is, will Hadoop will not work for small data sets? Hadoop will work for small data sets also, but the power will come when you put large data sets. When you give more data sets, it is something like giving the professor to teach for a LKG class. It does not mean that the professor will not teach the ABCD, but the capability of the professor is not fit for the LKG. It is for some good engineering people. It will be more beneficial. The same manner, Hadoop is for large data sets. It can process small data sets also, but the power of the Hadoop will come when you process large data sets. So it is an open source data management with scale-out storage and distributed processing. That is about the Hadoop. So we are going to go back with the previous. I'm sorry. Yeah. Yes. Hadoop is working on DFS. What is a DFS? DFS is nothing but distributed file system. What is a distributed file system is if you take an example, so whatever the DFS which is working in Hadoop is a HDFS, that is called as Hadoop distributed file system, right? It is a Hadoop distributed file system, that is called HDFS, right? So we have a one machine and I have a 1 terabyte of data. We have a one machine and I have a 1 terabyte of data, and this one machine with the 4 IO channels and each channel of 100 Mbps speed. So to process this 1 terabyte of data, it is taking nearly 45 minutes of time to process the 1 terabyte of data. Whereas if you take the distributed file system with 10 machines, and all these 10 machines are what? They are what? Commodity inexpensive hardware. They does not require high expenditure or a high configuration and all. They does not require. They are all commodity inexpensive hardware. That means what? Whatever the machines are there in our laboratories, which are completely idle, we are not making use of it. Why we are not making use of it? By thinking that its RAM is very less, its processor is very slow, the hard disk is very less, something like that. By keeping some points in our mind, we are not making use of those machines. But now the time came to make use of all those machines now, right? So we have the 10 machines we are having, for example, and the 10 machines with the same 4 IO channels. Here also 4 input-output channels. Here also 100 Mbps speed. To perform 1 terabyte data with distributed file system architecture, it is taking just simply 4.5 minutes of time. Whereas to process this 1 terabyte of data with 4 IO channels, it is taking 45 minutes of time, and whereas it is the distributed file system that is called as a Hadoop distributed file system is taking 4.5 minutes of time. It is so wonderful. There's a drastic change. So there is a lot of difference between 45 and 4.5 minutes of time. So like this, the working of Hadoop works in the distributed file system. And if you go to the differentiating factors, how, like I have told you that to provide a solution for the big data, Hadoop is playing a vital role, because what is a Hadoop? Hadoop is it process the large data sets over distributed commodity of hardware. How it processes it? Because of its differentiating factors. It has got some differentiating factors. What kind of differentiating factors it has is, it is accessible. The first important is, it is accessible is one differentiating factors. It can access over any commodity of hardware here. For example, how the Hadoop distributed file system works is, we're having the working of Hadoop distributed file system is based on master slave architecture. The working of distributed files, Hadoop distributed file system is based on master slave architecture. So we have a master node and we have a slave nodes here. We have a slave nodes here. I have got a slave nodes here all. So all these master nodes, sorry, all these slave nodes will work on the basis of the instructions of the master node. So master node will say, hey, you are free, you work it. You are free, you are free, you work it, you work it. So that means what? The working of master slave architecture is like how we are working on a software company, people associated with the programmers, team leads, all those things. So in that manner, we're going to work in the Hadoop distributed file system, right? So what are the differentiating factors of Hadoop is, the differentiating factors of Hadoop is, it is accessible everywhere. And its architecture is very simple because it is based on simple master slave architecture, and it is robust. Why it is robust here? It is robust because it has got a rich set of powerful flexibility is there. We can extend it at any level. And what is the scalability? Scalability is nothing but, for example, I would like to take the example of Vignan's Institute of Information Technology. Just imagine that previous 4 years back, Vignan was getting only 100 terabytes of, or some 50 or 10 petabytes of data to process. How much data? 10 petabytes of data. Suddenly, in 2015, there is a drastic improvement in the data of Vignan's Institute of Information Technology. Maybe from petabyte, it has gone to zettabyte. Previously, the Vignan Institute of Information Technology working with a cluster with only 40 to 50 nodes. These are all nodes. These are all slave nodes here. So previously, it was working with only 30 to 40 nodes. But now data has reached to how much now? Zettabytes. Previously, it was working with a petabyte. Now it is reached to zettabyte now. Now it is the necessity. It is the necessity to increase the nodes here. Previously, we are working with what? How many nodes? We are having only 30 nodes, for instance. Now we have extended it to 100 nodes. Why we have extended to 100 nodes? There is a necessity is there. What is the necessity? We have reached to zettabyte of data, not with the petabyte of data. So like that, it is showing what it is scalable. We can increase our nodes according to our requirement. So these are all the differentiating factors which is making the Hadoop to stand in a excellent manner. Right. And I would like to make a small comparison here, how Hadoop, it's about scale and structure here. We will take the RDBMS as a relational database management system, enterprise data warehousing system, massive parallel processing system, NoSQL. Yeah, very wonderful. This is NoSQL is a very wonderful topic. Now in the market, there are a number of NoSQL products are there, like HBase. Of course, HBase is a part of Hadoop ecosystem, and we have other NoSQL products like MongoDB, Cassandra. These are all the important NoSQL products. Now, the important thing is, what is the difference between the SQL and the NoSQL? The difference between SQL and the NoSQL is here. If you take on hand here. Okay, okay, something wrong here. Okay. I'll start here. Okay, not an issue. I'll work with this here. With my pen here, I'm going to work here. Not an issue. So coming to the SQL and no SQL, right? So people generally think that no SQL is means only we are saying no to SQL. No, 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 no. It is absolutely wrong. The meaning of no SQL is nothing but not only SQL. What is the meaning of not only? Not only mean what something else is there along with the SQL. That is called as NoSQL, right? So structured query language is there. That means SQL part is there, and in the NoSQL also. Along with the SQL, something extra is there. That is called as what? NoSQL. So NoSQL is nothing but here not only SQL. The meaning of no not SQL is nothing but here it is going to handle structured data as well as unstructured data, semi-structured all. But with concern to SQL, it is going to handle only structured data. The market has moved to NoSQL. Why the market has moved to NoSQL? Generation of big data is more. Why generation of big data is more? Because generating lots of unstructured data. From where you're getting lots of unstructured data? Facebooks, Twitters. Of course, I have told you the example from telecommunication side, from retail, from web and e-tailing, all those things in the previous slides we have seen. Right. So coming to the Hadoop here, so RDBMS is pure structured, whereas with concern to Hadoop here, it is a multi and unstructured it is, right? And with concern to processing, it is limited processing and sometimes no data processing. Like unstructured data is you are going to get, RDBMS will say, no, I can't, I am unable. And RDBMS will certainly raise his hand perfectly. And just for an information sake, to meet the market strategy, Oracle is very famous for structured query language. Now, Oracle Corporation has started its own product that is called the NoSQL. Everybody knows that Oracle is very famous for RDBMS. Everybody makes use of Oracle. But to meet the market strategy, Oracle also launched its NoSQL product, right? So, whereas with coming to the Hadoop here, its processing is coupled with data. Governance here, it is standard and structured, because in RDBMS we are going to have a structured data, employee number, employee name, something like that. It's structured here. This governance is what? Structured. It is loosely structured. Whenever you want, whatever you want, you can add here. Schema is required whenever you are going to write. Whenever you are putting insert, update and all, without schema you can't write, you cannot insert, you cannot update. Whereas schema is literally required whenever you are performing read with consent to Hadoop. Whenever you are performing reading, you require schema. What is schema? Employee number, employee name, all those things, right? Of course, data types and all those things. With consent to speed, RDBMS is more faster. Why RDBMS is more faster? Because in RDBMS we have a concept of indexing. With the indexing concept, we can retrieve more data faster. But with consent to Hadoop, writing is more faster here, whereas here reading is more faster here. Coming to the cost of license here, it is software license here, but here we need to take a support only, because as it is open source, so wherever required, we are going to take the support only license. Resources are known entity here, but here resources are growing and growing, growing and growing. How it is growing and growing? We have got number of added eco components are there, and it is best fit for processing unstructured data, data discovery, and for massive storage and processing. It is best fit for all these things, right? So we are going to move to the next slide. We have covered Hadoop distributed file system, the importance. What is the Hadoop? Yeah, of course, coming to the Hadoop characteristics also, it is reliable, economical. Yeah, the market has taken wide place for the Hadoop because of its economical. Because Hadoop is working on master-slave architecture. In master-slave architecture, all slaves are commodity inexpensive hardware. If a company will say that you implement, you perform the analysis, you invest some 5 to 6 crores of rupees means the company will think for a while, and the company will say that give me 1 month, 2 months of time, because they have to invest. But with concern to Hadoop architecture and all, there is no need to think. Why? Because whatever the inexpensive commodity hardwares are remaining for us, we are going to use it. We are going to put it in a cluster. We are going to make use of them as a nodes, and we are going to make use of their productive use also. Even though what amount of RAM is there, what amount of processor is there, what amount of hard disk is there, we're going to make use of it, right? So reliability, flexibility. What is the meaning of flexibility? Flexibility is nothing but Hadoop can process structured data as well as unstructured data. If it can process only unstructured, it becomes a completely inflexible for us. No? So it's completely, it becomes fails. But it is saying I can process structured data as well as unstructured data. So these are the some important characteristics of Hadoop, that is called the reliability, flexibility, economical, and scalability. Right? Yeah, we came into the most important part, short and sweet. I would like to have a small revise, then I'm going to go into the Hadoop ecosystem. So the time is 4:05. We have covered what is big data, what kind of big data consists of, what kind of problems we have faced with big data, with the processing the big data with the help of old traditional mechanisms. We faced problems regarding the searching, storing, analysis and all. We have seen the problems, and we have started making use of Hadoop, and how Hadoop has covered the problems, what kind of analysis we can do, all those things we have seen in the previous slides. Yeah, now we are almost we came to the important phase of the Hadoop here, big data Hadoop here. Yeah, this is called as the Hadoop ecosystem. It is our Hadoop ecosystem. In this Hadoop ecosystem, Hive is one component, Pig is one component, Mahout is one component, MapReduce is one more component, HBase is one component, HDFS is one more component, right? So for an understanding purpose, I will use some normal, the daily use terminologies for your understanding purpose, but it is not related to the Hadoop ecosystem. For understanding purpose only, I am using it, right? So Hive is for data warehousing system, right? So Hive and Pig are just normally we call it as a two eyes. What are two eyes? With our eyes, we have two eyes, right? We have one eye and another eye. So when you see with our eyes, then only we can perform the analysis. Otherwise, we cannot perform the analysis. You are walking on the road. You are walking on the road like this. Suddenly a snake came, right? Suddenly a snake came here. Since you have seen with two eyes, immediately you are going to take an analysis. What analysis? Suddenly you jump to some other place, safe place. So that is called as the Hive and Pig. That is called the quick analysis. So with the help of Hive and Pig, you can perform the quick analysis. So Hive and Pig eco components are basically used by the researchers, basically the people who are doing the quick research analysis. For them, this Hive and Pig is going to take a very important place. That is why it is called a data warehousing system and data analysis. So quick analysis we can perform. How quick analysis can be performed? Because you don't need to write too much of heavy code here. Just Hive is a query language, so normal queries you can write here as like structured query language, but not as simple as like the same SQL. Don't compare like that. Just for understanding purpose, I'm using it. And Pig or Piglatin is for writing scripting. So you don't need to put more focus towards writing program for Hive and Pig. So generally, there is a small confusion among various learners stating that Hadoop is very difficult. No, frankly speaking, it is very simple. Hardly you need to put your stress only in the MapReduce framework, which is a programming part, right? Remaining is all are simple things only. You don't need to take a lot of pressure on this, right? So Hive and Pig are called as analysis tools where we can perform quick analysis. They are just like a two eyes. What about Mahout? Mahout is a Sanskrit word. It's a machine learning actually, but for understanding purpose I am giving. Mahout is a Sanskrit word. Mahout is nothing but the person who rides the elephant or who controls the elephant is a Mahout. So what the Mahout will do? Mahout will ride the elephant and he will control. Stop here. Do this, do that, something like that. So here also, with the help of Mahout, we are going to control the cluster. So the people who are learning Hadoop, they are called as Hadoopers, and Hadoopers can settle their careers in three ways. What are the three ways? As a Hadoop administrators, as a Hadoop developers, as a Hadoop testers. Something like the people, as I said, Hadoop works on. As I said, Hadoop works on master-slave architecture. So these are all one master. We are having We are having slaves here, right? So how many nodes should work? How many nodes should work? How many nodes should process? All that instructions will be given by the Hadoop administrator. So the administration job is done by the Mahout here, and programming part is done by the Hadoop developers. And how the nodes are working and all, that is going to be tested by the Hadoop testers. But there is a more demand for the Hadoop developers, because we don't require more number of administrators, we don't require more number of testers, we require more number of developers only, right? Yeah. So that is about the Mahout. What about Oozie here? Oozie is nothing but it's a workflow system. It is going to take the scheduling. Hey, you need to perform this job, you need to perform that job. That scheduling job is going to be performed by the Oozie. So Oozie is a workflow system. It's like a brain thinking. So what kind of scheduling has to be implemented? What kind of mechanisms has to be implemented? So all those things are going to be implemented in the Oozie. Like generally, the Hadoop distributed file system follows the FIFO mechanisms only, first in first out mechanism only it performs. But it is not mandated to work with only FIFO mechanism. We can implement other mechanisms also. As a research point of view, we can implement other mechanisms. I can implement the round robin mechanism or the last in first out or something like that. I can implement. But we need to that instructions are going to be given by the Oozie, which is a workflow system, right? What about MapReduce programming? MapReduce is the heart of the Hadoop ecosystem. Like for a human being, I'm sorry, for any human being, any part of the human being is not working, he or she can leave for maybe a month or 2 months or a year, something like that. But if hat is not working, he will not leave. He will immediately die. The same manner, if MapReduce is not working, the complete cluster will die. Complete cluster will not work, because even though you are not writing program in the Hive, even though you are not writing program in the Pig, it is internally it will generate what code? MapReduce code only. So MR coding is very important part, and it is an important module of the Hadoop ecosystem. If time permits, we will see in the next webinars regarding the MapReduce, because it's a major part of the Hadoop ecosystem. In that we can see about how the program works, how practically the MapReduce works in the cluster, all those things we can see. So MapReduce is the heart of the Hadoop ecosystem, right? What about HBase? HBase is like a stomach. It's like storage part. Whatever the food you are eating, you are putting in your stomach here, right? And what is about HDFS? HDFS is a Hadoop distributed file system. It is also for massive storage. You can store whatever data is there, right? Now the most important point here is, some says that I don't know about all these things. I don't know what is Hadoop. I don't know about Hadoop ecosystem, what is Hive, Pig and all. Previously, I used to maintain my data by using the old mechanisms, that is called as structured data, using MS Excel and all. And I'm having some unstructured data like in a web files, video logs, all those data files are there, which are stored somewhere, but I'm not performing any analysis and all. So I want to perform all those job. Means what I have to do now, if you want to perform those analysis by using Hadoop ecosystem, then I'm going to use a Scoop and Flume. Scoop is nothing but using the Scoop. Scoop is a tool, mechanism tool. We can use with the help of Scoop, we can import and export structured data into the HDFS. Please understand, to perform any kind of analysis, first of all data need to be kept in the HDFS. It is mandatory. Unless and until you put into the HDFS, you cannot perform any analysis, right? So I'm putting data into HDFS. You can write MapReduce programming by writing Java programming, and you can perform the analysis. I'm very weak in Java. I can't write programming. Then I can make use of Hive or I can make use of Pig to perform the analysis. But most important thing is, before performing analysis, it is mandated to put into the HDFS, because we need to put into the HDFS. The file system has the data has to be kept into the file system first of all. Unless until we cannot perform any other analytical jobs. Similarly, if I am having unstructured data, what are unstructured data? Might you are seeing the images, web logs, video files, audio files. You want to perform the analysis. Then I can make use of Flume, and using the Flume tool, I'm going to put my unstructured data into the HDFS. Again, to perform the analysis, I may write my MapReduce programming, or I may implement Hive, or I may implement Pig to perform the analysis. So like this, the Hadoop ecosystem works on, right? Short and sweet. I would like to revise this because as it is a very important part. The time is 4:15. I think we cannot cover the remaining, but I will try to cover the Hadoop architecture, and then we may wind the session because hardly 15 minutes time is there for me. Right. Coming to the Hadoop ecosystem, Hive and Pig are my analytical tools. Something like two eyes. This is my stomach, this is my heart, my two legs to import and export data into the HDFS. So I can import and I can export the unstructured data using the Flume to the HDFS. Using the Scoop, I can import or export into the HDFS, and then I can perform the analysis either by writing MapReduce, or either by writing Hive, or either by writing Pig scripting, right? So like this, the Hadoop ecosystem works on. So the ultimate thing is that we need to put our data into the HDFS. So a lot of analysis we can perform. We can take weather data sets. We can take, of course, weather is a very simple thing because a couple of 1900 or a couple of 50, 60 years of data we can take, and we can do the analysis. What kind of analysis we can do? Which year has got a less temperature, which year has got a highest temperature, and with that we can make a study that how about our ecosystem of our nature. We can find out how the temperature is raising, what are the reasons of that. So a lot of research can be implemented by taking the temperature data sets also. Okay, and similarly we can take health data sets also. Health data sets are wonderful project actually. We can perform analysis by performing the health data sets, where it shows what kind of diseases more people are affected. Like if you take the data sets of one hospital, maybe Apollo or something like that, what kind of diseases are getting more, that kind of analysis we can do with the help of the data sets of the patients. So number of analysis can be done with the help of Hadoop ecosystem. Even for the Flume also. Flume, of course, the Facebook is making use of all these things now to perform the analysis now. And right now to perform the analysis, Facebook, Hive has been used. Hive has been used by the FB to perform the analysis, right? So likewise, there are a number of examples can be done. Even before releasing the movie, number of people keeps on tweets. This song is good, that song is good, something like that. The fans keep on tweets. So with the help of tweets also, they can perform the analysis, and they can say that whether this movie is going to be hit or not, something like that. They can make a predictive analysis with the help of unstructured data, which can be performed with the help of Flume. Of course, Scoop is for structured data only. Yeah. This is about Mahout. Of course, I have told you about Mahout. Yeah, we are into the important phase. Hadoop core components here. Hadoop core components. So I would like to make use of my document. Yeah. Yeah. Coming to the Hadoop cluster, or we call it as the Hadoop architecture, how it works on. The Hadoop cluster is nothing but normally any set of loosely connected or tightly connected computers that work together as a single system is called as a cluster. In simple words, a computer cluster is used for the Hadoop is called as a Hadoop cluster. And Hadoop cluster works on low cost commodity hardware. Because of this reason, the Hadoop has taken a wide place in the market, right? So just as the time is running short, actually to discuss about Hadoop cluster, a minimum 30 minutes of time is required. But now I'm having only 10 minutes of time. But I'll try to complete this job. So Hadoop cluster, this is a Hadoop cluster architecture. So these are my racks. In these racks, I'm having a nodes. So we have nodes, right? Node 1, node 2, like that. In another rack also, I'm having a nodes. Likewise, I can have n number of racks, right? And all these nodes are going to communicate with one another, and all these racks are going to communicate with one another with the help of what? Rack switch. And these rack switch are going to connect with the core switch, and the core switch is going to connect with the Hadoop cluster. For example, I have made a Hadoop cluster. One cluster is in the India, another cluster is in Germany, another cluster is in London, right? So in this cluster, I'm having some 1,000 nodes are there. In this cluster, I'm having some 1,000 nodes, and here also I'm having 1,000 nodes. So with the help of Hadoop cluster, that means what? Hadoop is becoming cloudy also these days, right? So all these clusters I can connect with the help of cloud, and now I can get the power of all these 1,000 nodes. That means 3,000 power of nodes I can get it, and I can process it. That means we can see that there are a number of applications has been stopped. The number of applications has been stopped because of lack of resources. Why there is a lack of resources there? Because for the calibration of cancer cells and all, we require lots and lots of resources. Since resources is lacking, the result is taking nearly 10 days of time. Likewise, even big scientific calculations also taking lot of time to calculate because of lack of resources. Now I can join through the Hadoop cloud, and I can get the power of cluster of Germany, cluster of London, cluster of India, and all the 3,000 power I can take, and I can calculate it. There is no need to search for a big hard disk or a heavy amount of RAM. No need of spending too much of time, and we can make use of all these things happily. Right. So you can see that the same image I'm extracting for your understanding purpose. So we have, these are all the most important thing, right? So we have a Hadoop cluster. So we have nodes here. So this green color is your master node. This is your master node here. This is your slave nodes here. In master node, we have two daemons. What are the two daemons? Name node and job tracker. In slave nodes, we have got two daemons. What are the two daemons? Data node and task trackers, right? So I already told you that the Hadoop cluster works on the basis of master-slave architecture. So in the master node, we have got two daemons. What are the two daemons? Name node and job tracker. In slave machines, also daemons will be running, right? So what are the two daemons will be running? Data node and task trackers, right? So this is the architecture of the Hadoop cluster. So to make it more understandable, I have divided the cluster into three components. What are the three components? Client, master, and slave. Client, master, and slave, right? If you take like this, look at like this. So client is there. What the client wants? Client wants only one thing. Client will give some data, maybe unstructured data or structured data. Some data he will give. That's it. What the client want? Client want analysis. Clients want what? Analysis only. For example, if you take the analysis, if you take the any college, a Vignan Institute of Information Technology, I would like to take. So in that, what is going to happen is every now and then we want to perform the analysis, how many students has been placed, how many students has been passed, how many students has been failed. So all these are what analysis. Every now and then we want to perform the analysis, right? So to perform, the client wants that the client will give the data, and the client only wants the result analysis. The client will never bother about how master is working, how slaves are working. He will never bother about all those things, right? So client is going to interact with the MapReduce and with the HDFS, right? So in HDFS, we are having two daemons, that is called as the name node and secondary name node. So that is called as the master node here. So in slave nodes, we have got, these are all slave nodes. The purple colors are all your slave nodes here. So in slave nodes, two more daemons are running. That's called data node and task tracker. Task tracker is a slave to the job tracker, and data node is a slave to the name node, right? Task tracker is a slave to the job tracker. That means, for your understanding purpose, we have a master node, we have a slave node. In every slave node, two daemons will be running. What is that? That is called as data node, and another is task tracker. Here also data node and task tracker. So these are nodes are working here. So to work on this data, the name node The name node will give data. Name node will not store anything. Name node, because master node does not store any information. All information will be stored at the slaves only. All burdens are on the slaves only. See, that's the difference between the client server architecture and master slave architecture. In client server architecture, the whole burden will be taken by the server. In master slave architecture, the master will try to keep all the burden on the slaves only, right? So the name node will put data, say, and take care of data. Once data has been given, some programming mechanism, some algorithm has to be written to perform the analysis. That algorithm is implemented with the help of the task tracker, and that job is done by the job tracker, and that programming job is done with the help of what? MapReduce, or by Hive or Pick. And name node will keep information regarding the data node, how data node is working, because at every minute the data node has to supply a heartbeat to the master node. Hey, I'm alive, I'm doing a work, because we are going to get the heartbeat in our body also. If heartbeat is not there, it's gone case. Similarly, here also, every minute the slave node is going to send a heartbeat. There is a heartbeat mechanism is there. There is inbuilt mechanism is there in the Hadoop architecture, right? So the slave will give a heartbeat to the master, stating that I'm alive, I'm alive. Otherwise, if heartbeat is not getting from the slave to the master, means what? The node is not working, something goes wrong. There may be some hardware failure. Then what is going to happen at the time? Immediately there will be a fault tolerance. If employee is living in the organization, the organization will not stop. Immediately what they will do? Immediately they will appoint one more person, or the person who is in the standby mode, they will make it active. Similarly, this node is now free. This node is not working. What is going to happen? This node is not working because of some hardware failure. Immediately that job is going to be carried by the other node. That is called what? Fault tolerance, right? So we have a client. So client submits MapReduce jobs, describes how data should be processed. What is your analysis? What is your requirement? I want how many students has been placed in the year of 2014, in which company they have been placed in the college. So, and ultimately the client retrieves the things. What it retrieves? The kind of students has been placed in what companies. That is the analysis, right? Coming to the master node, the master node consists of three things: name node, secondary name node, right, and job tracker. So job tracker is for the purpose of writing the MapReduce, to write the job. So job for a data node, for slave nodes, two dimensions will be running. What is that? Data node and task tracker. Data node will be keeping about the data, and task tracker will be performing the task. How task is going to perform? With the help of the MapReduce coding. What about name node here? Name node does not store the file, but only the file's metadata. What is the metadata? Metadata is the data about data. What kind of file the slaves has stored? How much amount of data has been stored by the slaves, and what kind of processing the slave node is performing. Whether the data is having read permission or write permission, all those things are going to be stored in the metadata, right? So name node oversees the health of data node and coordinates access to the data stored in the data node, right? What about job tracker? Job tracker coordinates the parallel processing of data using the MapReduce, right? What about secondary name node? Secondary name node is nothing but here. See, I said that the Hadoop works on the master-slave architecture. So I have a master, I have a slaves. I said that if this slave is not working, immediately there will be a fault tolerance, and this will be started working. Similarly, we can assume that even the name node also may not work. There is no such thumb rule that only slave nodes will always only fail. There is a failure in the slave nodes. No. Name node also may not work sometimes. Name node is also a machine. The name node may also get some failures, hard disk problem, or some problem it may also get. So at that time, name node is storing what? It's not storing the data. Data is stored by the slave nodes. Name node is storing the metadata. What is metadata? Data about data. If metadata is lost, means, my God, it will be a big issue for us. That is why secondary name node, what it will do? Secondary name node, what it will do is every 1 hour it will connect to the name node, and it will take the metadata information. So here also there is a fault tolerance is there. If name node not working, we can get the metadata information from the secondary name node, right? So the job of secondary name node, The job of secondary name node is to contact name node in a periodic manner after some interval of time. By default, it is 1 hour. We can change it for 2 hours or half an hour depending upon our requirement, right? So short and sweet. I'm repeating once again, right? As the time is 4:29. Right. We have a master node. We have slave nodes. In the master node, we have got a 3 dimensions: job tracker, name node, and secondary name node. Job tracker, task tracker. Task tracker and data node are 2 dimensions running in the slave machine. Task tracker is a slave to the job tracker, and data node is a slave to the name node, right? And once the data has been given, to the slaves, task has to be implemented. That means what? Some algorithm has to be implemented with the help of what? MapReduce program, right? So like this, the architecture of the Hadoop works. You can see the Hadoop architecture: client connecting with the master node. These are all your slave nodes. In all these slave nodes, what is happening? We are having the data node and the task tracker. In master node, we have a 2 dimension that is called as a name node and the job tracker, right? In secondary name node, it's going to connect to the master node. It's going to take the metadata every 1 hour or 2 hours, likewise, right? Right. The most important thing I would like to do here, some important thing is HDFS provides the most important thing. When processing is done on data, all here in Hadoop, what is going to happen is when processing is done on the data, algorithm is moved across the data nodes rather than the data to the algorithm. What is the meaning of this? Previously, if people is having a knowledge of JDBC connectivity, if I'm writing a JDBC program, with the help of Java program, I'm connecting to Oracle, and then I'm accessing all data. I'm putting in a cache memory, and from there I'm printing the data. But since we are connecting to structured data, we can put into the cache. But if we are connecting to unstructured data, it is very difficult. But with consent to Hadoop, it is different. What is happening? Wherever data is there, let it be. We are not going to move data because moving data is very expensive these days compared to placing the algorithm. So that's what we are doing now. Wherever data is there, let it be there, not an issue. We are going to make use of Scoop, or we are going to make use of Flume to import it into the HDFS, and then I'm going to run my algorithm, because moving the algorithm is simple and cheap compared to the moving the data is very expensive. That's what here I'm telling. When the processing is done on the data, algorithm is moved across the data nodes rather than data to the algorithm. That is why it is cheap, and it is called as what? Data locality also. And we have a fault tolerance also, right? So we have covered so many things in our sessions. Almost Hadoop core components, how the MapReduce has worked, and how the HDFS cluster has worked, architecture, all these things. See here, we have got name node and data nodes. I have placed a name for name node. I have kept a rich car because it's a master node. For data node, it is slave node, so I kept a small taxi, something like that. So name node consists of the metadata. So metadata consists of list of files, list of blocks, something like that. So all these things we have covered. So today's we have covered about the what is big data and what are the importance of big data, how Hadoop is providing the solution, what is a Hadoop cluster, how the Hadoop cluster is playing the important role. So all these things we have covered in today's session. How job tracker has performed the job. I am unable to cover the anatomies of file write and read. If some other time I am going to cover the remaining things, all these things. I am unable to cover all these things as the time is short. So we'll cover in the next sessions how the Hadoop really works, what kind of configuration files are there, how MapReduce really works. All these things we are going to cover. I'd like to have any questions or any clarifications.
Somebody is asking for examples of big data.
Examples of big data.
Yes.
So these are all the customers who are generating big data, right? So these are all the examples for us. So web and detailing is generating big data. The biggest company is what? eBay is the biggest company which is generating big data. Telecommunication is generating biggest big data. The China Mobile is the biggest company. And government, Aadhaar has also generated the big data. Next Bio also generated big data with consult to healthcare and life sciences. And JP Morgan Chase also generated a big data with consent to banks and financial services. Sears started working with Hadoop. Previously, Sears used to work with Oracle to perform the analysis, but now Sears started working with the Hadoop. Why? Because Sears previously working with the structured data, but Sears started getting with working with structured, unstructured, semi-structured, all kind of data. That is why Sears started working with the Hadoop, because it is unable to process the unstructured, semi-structured data by the Oracle.
Should just one piece of data be of NTB or NPB? Hello.
I didn't get you.
Should just one piece of data be of NTB or NPB?
It can be NTBs, NPBs.
One piece means just one single record.
Okay. I understood the question. It is something like we are having a block here. So this block, maybe I'm going to divide this block. Of course, we have not covered that concept. So this block, we are going to, basically it is going to divide into 64 MB, it is going to be divided. And this block will be processed at one slave node. Similarly, this block will be processed at one more node. Similarly, another block will be processed at another node. So the entire, maybe a terabyte or a petabyte, 1 piece, whatever the amount could be, we're going to break into number of pieces, number of blocks, and then the processing is going to happen.
One gene file may be few GBs to NTB. Is it a big data?
Yeah. Yes, obviously it is a big data. Sorry, sir, come again the question.
One gene file may be few GBs to NTB. Is it a big data?
Obviously, it is a big data. As long as it's increasing its size, it will be big data. As long as it is becoming unstructured, it becomes a big data.
Can I apply big data in machine learning algorithms? If yes, how?
Can I apply machine? Yeah, certainly we can apply machine learning algorithm. How means we need to show it practically. If I get a session one more, then I am going to explain how practically we can apply. But certainly we are going to apply in the machine learning. It's an important concept, and we can apply. There is not an issue.
Is there any other tool for processing big data?
Of course, people are making use of Hadoop now. People are making use of, in the Hadoop ecosystem. Some people making use of writing MR code, MapReduce, and some making use of Hive. Some making use of Pig, and some even people are going for other things like Spark is also there to perform the analytics now, because MR has got its own limitations, because in MR every piece is going to be broken into number of several chunks, and it's a little bit time consuming. Every text has to be broken into map, and then aggregation has to be done. So like that, to overcome, the technology has been upgraded with Spark, these things. So we can perform, other tools are also there. We can implement it. Not a problem.
Looks like real intelligence will be to flume and scoop all appropriate and related data, right? Can this process be automated, say for given keywords or key maps?
Yeah, it can be automated. It can be automated because Flume and Scoop tool has meant for that only, to import and export the unstructured and structured data into the HDFS.
What is the major difference of Hadoop and big data?
Oh, oh. I'm feeling a little bit bad for this question, but I would like to answer this question. Big data is a bigger in size. So we have got a lot of data here. Some data is structured, some data is unstructured, some data is semi-structured. Don't get confused with semi-structured and unstructured. Facebook data, Twitters are all called unstructured data. Semi-structured are what your XML files and all, semi-structured data. Structured data, everybody knows, there's not an issue. Now, these are all big data. What the Sears is getting problem, as long as Sears is working with getting structured data, Sears was very quite happy. But once the Sears started all this mixed data, then the problem arose. So for that purpose, the solution is what here? Hadoop. So that is the difference between big data is always bigger in size. It is large data sets where traditional approaches cannot be implemented to perform the analysis. Why? Because unable to store massive data, capturing is difficult, analysis is difficult, all these things are difficult. Just I am taking the example of Facebook itself. Facebook analysis is very difficult task. Everybody has got Facebooks now. Now, Hadoop is providing a solution for the big data. It's a solution. The image itself is saying it's a solution, right, Mark?
How big data can be useful for e-governance application?
Oh yeah, my God, it is a wonderful question. For e-governance, Hadoop plays a vital role actually, because if you take the example of Aadhaar has generated so much good data. It has taken our image, our thumb image, and the eyelid information. All the information it has taken. So how the Aadhaar is going to provide that governance is, for example, just for understanding purpose, I would like to give an example. Just imagine that there is a one guy is there. He is driving one big BMW car, and every day he is pouring. Then ultimately they'll find that this boy is nothing but it's just simply a free boy type. He's not doing any work. Then the job over. No. Then the production starts here. Then the analysis starts here. The government plays the vital role here. What he will do now? What kind of business is performed by this father? What kind of job he is doing, whether how much, what is the income state of his father, and how he is generating that amount. Is it a black income or a white income? It is a tax paid or not paid? So all these things are going to play a vital role with the governance. And governance is possible only with the help of Aadhaar. And Aadhaar governance is only possible with the help of analysis, with the help of analytical tools like Hadoop or Informatica. All these things can be implemented. And the fraud detections, welfare schemes, who should get the real scheme, welfare scheme should be given. Like we are having a white ration card is there, so we have got some Arogyashri is there. So who are really eligible for all these things? That is all concerned with governance. That is all possible with the help of Aadhaar data only. If you perform the Aadhaar analytic, then all these fraud detections, welfare schemes, all can be implemented for the governance. It plays a vital role for the governance.
Ma'am, there are a few more questions. I will send them to you by email. Maybe in the next session you can
Okay,
address
sir.
them.
Okay, sir. Right, sir. Because the
Okay.
time is
Thank you
over.
very much for the webinar, ma'am.
Thank you, sir. Thank you very much.